Hi, so we just did a video on how to make a light box out of one of these things. It's an LED panel actually. Now these LED panels are all over the place because they're becoming the most popular way to light. And there's a variety of prices, like there always are with these things, but you can get them as low as £12, which is unbelievably cheap when you think about it. Now in this box you'll get a transformer to plug it into the mains, and then one of these, which is obviously the light panel. Now, to be honest, there isn't much to these things, and what we're going to do is take one apart and have a look at what's actually inside it. Now, a lot of people are really interested in how would you convert this to work from the mains to a battery. Now, it's a bit of a cheat actually, because the conversion isn't strictly necessary. This is already a piece of DC equipment. It's meant to run on DC. What happens is this thing takes your house mains, your AC, and here in the UK it's 230 volts, in other parts of the world it's 110. It takes the AC in, and this bit of electronics will convert it into a DC output right there, and that just plugs into your DC. So essentially these things are already direct current. If we just didn't use that and plugged that in, as long as the battery gave enough volts, it would work just fine without doing anything else to it. Then there are a couple of wrinkles to it, so let's take this apart and have a look at the inside. Taking it apart is a piece of cake. On the back you'll either see some clips, or maybe the frame's clipped in, and this one's got a lot of little screws in it. We just undo the screws. So once you've removed the screws or clips or whatever it is you've got, actually these will just come apart really easily. I mean, remember they were 12 quid, so these things have been mass produced out of really quite cheap materials. We lift off that back. It's a bit of pressed steel, and it's incredibly thin pressed steel. So as we want to put this thing back together, you have to be careful with this stuff because it will bend at the slightest pressure actually, and then it'll ruin putting it back together. So do be careful with it because it's really thin stuff. So I put that out of the way. Then we have a look at the internals. You'll find you've got a wire at the bottom and a wire at the top, and the top wire will be the one that comes out. And there'll be various kinds of bits in here, but normally they're this kind of thing. Here we have a piece of packing material that is little more than bubble wrap actually. If you've ever taken apart those LCD screens, and we've done lots of those on here, you'll see that the main components here are actually very similar to an LCD screen. So we have a piece of reflective white plastic. And that just makes sure that all of the light is being reflected out of the light box and not the other way, sorry, the light fitting. Then what you'll have is a piece of acrylic that has either been pitted or it has a Fresnel lens pattern on it or a linear pattern, and this takes the light from the edges, passes it through, diffuses it out, so we get a diffused light across the surface. Now it'll be a little bit spotty, and sometimes the next bit is two bits. Either there's a diffuser piece, which is a piece of frosty plastic, and then another piece of clear plastic on top, or there's a combined piece like this, which is both the plastic guard and a diffuser all in one piece. And that's all there is in there. Now when we look at this, what we can see are strips of LEDs. Sometimes they're like this, where you have them down either side, sometimes they're around four sides, it just depends which one you've bought. And if you look here, you'll see that the bottom of this LED is connected with this wire to the bottom of this LED, and the top of the LEDs, one is red and one is black. So these are connected in series. Now all of the information you want about these are in fact on a label on the back of the thing, or on the box itself. So it says on the box, voltage 22240, 4014 LEDs, lumen output is 2880 lumens, and colour temperature, and so on. It's all on the back of the box, or it's all on the label, and the other place is on the transformer. So this transformer tells me it's a 230 input and somewhere between a DC 27 to a DC 42 volt output at 900 milliamps. Now we know this is 36 watts. So at 36 watts, at more or less an amp draw, we're going to have more or less 36 volts. Now that's a bit high. And you could run it from a battery bank if you liked. You 2 or 3 batteries in a row and you'll get 36 volts. It's a little bit high, so what we can do actually is rewire this so that it's in parallel. Because remember, this is just in series. Power comes in here, zips around there, down there, out there. So it's in series. What we can do is split that wire, put a separate wire going up here, and there's a little channel to hide it, another wire going up here, and then we'll have 2 wires coming out for this strip, 2 wires coming from that strip. We join the positive to the positive, the negative to the negative, and then we'll have wired those in parallel. So what I'll do is I'll do that and then give you a close-up of it. Okay, so this bit here is where the LED light originally began, and it had a red wire to it, so we know that's the positive. Now all I've done is solder on an extension red wire so I can work with it. And if we follow that strip down, if that was the positive, this bottom end one here must have been the negative, obviously. So what I've done is solder on a bit of black wire, so now I don't have to think about it. Now we connected these in series, so if this was the negative, it means that when we come to this side of it, the other LED strip right there, its beginning, it must have been positive. So I've soldered a bit of red wire on there so that equally I don't have to think about that. And if we follow that strip all the way back up to the other corner, that obviously is the negative. Now we know that when we checked it out because there was a black wire soldered onto that one. So I put an extension black wire. And that sorts out the positives and the negatives for me. Now let's put this thing back together. The rewire really is a piece of cake. I've laboured it a bit just to make sure that you were clear on what's going on, but it really is a piece of cake. So all you have to do now, obviously, is clear those wires out of the way and then put the layers back in just as you took them out. I obviously stacked mine up in the order that they came out, so I don't even have to think about that. Just clear out the wires and pop those things back in. Okay, so now we need to rejoin those wires, but as I say, this time, instead of doing it in series, which is how they were before, we're going to do it in parallel. And what that means is you take the 2 blacks and you join the black to the black and the 2 reds and you join the reds to the reds. Then give it a bit of extension so that the thing can come out neatly and put the back on. That's all the wires brought together and connected black to black, red to red. I've used a bit of Kapton to hold everything down. Originally it was just sellotape, so Kapton's going to be fine. And now we can put the back on. So put that back in place and replace the screws. That's the whole thing back together. Now each of those strips is around about 24 volts as it happens. We know that the maximum limit that this transformer will put out is 42 volts and 900 milliamps. So because we've changed it from series to parallel, we're going to be drawing about 1.8 amps out of whatever supply we could put it from. So you need to make sure that your wires can cope with that current. Now to be honest, that's a really poor low current, so lots of wires are going to cope with that, even this thin stuff I put on, so this sort of stuff is going to be just fine. But you are drawing more ampage, but you're drawing less voltage. Now obviously we want to run this off of batteries, so if we were running it at 48 volts, we'd need 4 batteries. 24 volts, we need 2 batteries. So I've linked up a couple of batteries here, a couple of car batteries at 12 volts each, and then I'm just going to touch this to the positive, and there we go. That's our light panel. Pretty bright, eh? So, as I said, the conversion, dead simple. It's already a DC. Chances are that it draws a lot of DC voltage and it'll be wired in series. Rewire it in parallel, you'll drop the voltage, but you will raise the amps. But that's really how you go about converting one of these LED panels to run off of batteries. Anyway, I hope you enjoyed the video and thank you very much for watching.